In the domain of science, a significant question about what existed before the Big Bang has sparked vast discussions and captivated scholars for decades. This profound inquiry not only tests our ability to unravel the universe but also challenges the very limits of human knowledge. Imagine standing at the edge of existence, peering into the vast unknown, and contemplating what lay there before our universe was conceived. The event of the Big Bang marked the dawn of time, space, and everything we know. But was there a moment before this? Perhaps there was a state of nothingness, a calm before the roaring expansion began. Or maybe something even more enigmatic existed before time itself. As we delve deeper into this mystery, science takes us on a journey beyond the universe's origin into ideas that defy our understanding. Physicist Brian Cox, known for his contributions to the wonders of the universe, suggests that something extraordinary might have existed before the Big Bang. He encourages us to rethink our perception of reality and existence. In this exploration, we will delve into the science, theories, and fascinating secrets that could explain what existed before it all. We'll examine concepts like cosmic inflation, quantum fluctuations, dark energy, and even multiverses. The answers we uncover may astonish you but could also provide new insights into our place in the universe. Understanding the Big Bang. To comprehend what might have existed before the Big Bang, we first need to understand what the Big Bang truly was. In science, the Big Bang refers to the moment when the universe became incredibly hot and dense, rapidly expanding to create all matter, energy, and fundamental forces. When we look at the night sky, we see evidence of this fiery beginning as galaxies spread out from a central point. But why did this happen? Was there a time before this dense, hot origin? The theory of cosmic inflation. According to the theory of cosmic inflation, there was indeed a before. It was an era of emptiness or silence. Cosmic inflation suggests that before the Big Bang, the universe existed in a state that was cold, empty, and smooth, a sort of cosmic vacuum. However, this vacuum wasn't entirely empty. It contained a tremendous amount of energy that fueled the rapid expansion of space itself. This expansion, known as inflation, occurred so quickly that it set the stage for everything to follow. In a fraction of a second, space expanded at staggering rates until the expansion slowed, and the energy transformed into matter, particles, and the forces we know today. But what was the nature of this energy? Why did it emerge seemingly from nowhere to create the universe? And why did it stop? The inflationary multiverse. Scientists believe this rapid expansion created patches of the universe, each undergoing its own Big Bang. Imagine a fabric stretching infinitely with small air bubbles forming, each bubble representing a universe, including our own. This idea, called the inflationary multiverse, suggests there are potentially countless Big Bangs and an infinite number of universes. Our universe is just one among many, challenging our understanding of existence and prompting us to consider what else is out there. The concept of nothingness. The idea of nothingness before the Big Bang is theoretical, not literal. Even if we removed all energy, particles, and radiation from the universe, it wouldn't truly be empty. Our universe is permeated with dark matter, dark energy, quantum fields, and various forces intricately woven into its fabric. Even in its most stripped-down state, space still produces new forms of energy. This realization perplexes scientists, as it implies that true nothingness may be impossible. For example, there's a concept called zero-point energy, which represents the lowest energy state of quantum fields. Even in this state, particles can appear and vanish, creating a faint hum of activity even in the emptiest void. This challenges our understanding of a true vacuum and suggests that even before the Big Bang, there was something. Eternal inflation and the fractal universe. One of the most fascinating theories in modern cosmology is the idea of eternal inflation. If inflation could create our universe, it's possible that it continues endlessly. Brian Cox describes a breathtaking inflationary multiverse where universes are constantly being created and expanded. Imagine each Big Bang as a spark igniting another universe, while inflation occurs in different regions, creating countless other universes. This process could theoretically happen forever. This idea of massive universes birthing others leads to a compelling concept of a fractal universe, where each new universe may, in turn, create its own Big Bang. Each universe exists as a separate, independent space unaffected by the others. Given the rapid expansion of space, this hypothesis is both exciting and unsettling, as it suggests an infinite multiverse with no clear beginning or end. Imagine our universe as just a speck in a vast cosmic structure, endlessly growing and continually creating new universes. Quantum field theory and the nature of reality. The way we understand nothingness changes when we consider quantum field theory. According to this theory, the universe isn't a collection of matter floating in space but a complex network of energy fields filling the universe and interacting to create everything we observe. These fields are like invisible oceans, with particles acting as waves or disturbances. Even when fields are at their lowest energy level, known as the vacuum state, they remain active. Particles can appear and disappear in these fields, temporarily borrowing energy before returning it. This phenomenon creates virtual particles, entities that exist momentarily and then vanish, leaving only faint traces of their presence. The idea of virtual particles challenges the notion of true emptiness. Even in an empty universe where all matter, radiation, and energy are removed, quantum fields would still exist and remain active, sometimes generating transient particles. Dark energy and the universe's expansion. Dark energy is a mysterious force currently driving the accelerated expansion of our universe. But did dark energy exist before the Big Bang? Some theories suggest that dark energy, in a much stronger state, may have powered the inflationary phase, causing rapid expansion. The existence of dark energy today implies that even if our universe were stripped of all matter and radiation, this force would continue to expand the fabric of spacetime. The role of dark energy before the Big Bang. Dark energy's enigmatic presence today raises questions about its role in the early universe. Was it a dormant force waiting to awaken during the inflationary phase? Some theories suggest that dark energy existed in a more concentrated and dynamic form before the Big Bang, driving the rapid expansion of the cosmos. The idea that dark energy could have existed in a pre-Big Bang state aligns with the hypothesis of quantum fields that pervade all of space. Even before particles, forces, and matter were formed, these fields could have contained the seeds of energy needed to ignite the Big Bang itself. The eternal cycle of universes. If dark energy played a central role before the Big Bang, it could also suggest a cyclical universe model. In this framework, our universe may be just one in a series of countless cycles of creation and destruction. The cyclic model suggests that universes expand and contract repeatedly, with each Big Bang representing the start of a new cycle. This raises profound questions about the nature of time and existence. If time as we understand it began with the Big Bang, does it cease to exist between cycles? Or is there a higher dimensional construct of time beyond our perception? The multiverse and our place within it. The inflationary multiverse theory proposes that our universe is one of many, each governed by its own unique physical laws. Some universes might have different constants of nature, entirely different particles, or even alternate dimensions of space and time. This concept profoundly alters our understanding of reality. If the multiverse exists, it implies that our universe is not unique but rather part of an infinitely complex and diverse cosmic tapestry. Furthermore, the multiverse theory poses philosophical and existential questions. Are we simply a product of chance, existing in one of the few universes where conditions allowed for life? Could other forms of life exist in parallel universes, governed by laws we cannot comprehend? Quantum fluctuations and the origin of everything. Quantum mechanics introduces the idea that particles can spontaneously appear and disappear, even in a vacuum. These quantum fluctuations could have been the catalyst for the Big Bang, with tiny energy variations sparking the rapid inflation that created our universe. If true, this suggests that the nothingness before the Big Bang was not a void but a seething cauldron of potential energy. Even in the absence of matter, quantum fields ensured that the universe was never truly empty. Bridging science and philosophy. The question of what existed before the Big Bang is as much a philosophical challenge as a scientific one. It forces us to confront the limits of human understanding and the nature of existence itself. Some scientists, such as Stephen Hawking, argued that asking what came before the Big Bang might be meaningless because time itself began with it. Without time, the concept of before loses its significance. Others, like Brian Cox, suggest that exploring these questions could lead to breakthroughs in our understanding of reality, revealing insights about the fundamental nature of the universe and our place within it. The quest continues. While we may never fully comprehend what existed before the Big Bang, the pursuit of answers drives scientific progress. Every new discovery, from quantum mechanics to cosmology, brings us closer to unraveling the mysteries of the universe's origins. As we look to the future, advancements in technology and theoretical physics may provide new tools to probe the edges of existence. Whether we discover evidence of a multiverse, understand the true nature of dark energy, or uncover the origins of quantum fields, the journey itself is a testament to human curiosity and ingenuity. The question of what came before is not just about solving a cosmic puzzle. It's about understanding ourselves and our connection to the universe. Each discovery brings us one step closer to answering the ultimate question. Why is there something rather than nothing? Prompts a significant inquiry. Assuming dark energy existed before the Big Bang, might it have ultimately created the conditions that led to the introduction of our universe? And could the Big Bang have been not a singular event, but rather part of an endless sequence of cosmic cycles? In cyclic cosmology, the universe expands, contracts, and is reborn in an unending rhythm. During the contraction stage, all matter and energy break down into an extraordinarily dense and hot state, resembling the conditions of the Big Bang. From this state, a new expansion begins, creating a new universe. This pattern of a big crunch and Big Bang repeats endlessly, with no clear beginning or end. One version of this hypothesis, known as the ekpyrotic model, suggests that our universe is the result of a collision between two higher-dimensional membranes, or branes, within a multidimensional space. When these branes collide, they release a tremendous amount of energy, triggering a Big Bang-like event and forming a new universe. The cyclic model challenges the conventional notion of time and beginnings. It suggests that the universe is eternal, constantly reproducing itself in a dance of destruction and renewal. This perspective shifts the question from what came before the Big Bang to what drives the timeless cycles of the universe. Quantum fluctuations and the birth of the universe. Another compelling idea is that the universe emerged from quantum fluctuations in a primordial vacuum. According to quantum mechanics, even in a vacuum state, energy levels are never completely stable. Tiny fluctuations occur spontaneously, creating brief disturbances in the fabric of spacetime. Some scientists propose that one such fluctuation might have been powerful enough to ignite the creation of the universe. These fluctuations could explain why the universe appears to have started from an incredibly small, dense, and hot point before expanding into what we observe today. This idea aligns with the concept that nothing is inherently unstable. If even a vacuum state can give rise to quantum disturbances, it suggests that the creation of the universe could have been an inevitable outcome of the fundamental properties of quantum fields. The multiverse and infinite possibilities. The concept of the multiverse expands these ideas by suggesting that our universe is just one of many. If inflationary theory is correct, the rapid expansion of space could have created countless pocket universes, each with its own unique properties, laws of physics, and initial conditions. In some versions of the multiverse hypothesis, universes may interact or influence one another in subtle ways. Others suggest that each universe exists independently, with no communication between them. The implications of the multiverse are staggering. It raises questions about our place in the universe and whether our universe is ordinary, unique, or just one of infinite variations. Philosophical and religious implications. The exploration of what existed before the Big Bang also delves into profound philosophical and theological realms. If reality as we know it began with a Big Bang, does it even make sense to ask what came before? Does the concept of before require redefinition in the context of a timeless state? For some, the mystery of the universe's origins points to a deeper metaphysical reality. For others, It highlights the limitations of human understanding and the need for humility in the face of the unknown. A journey without end. As science pushes the boundaries of what we know, it becomes clear that the question of what existed before the Big Bang is as much about the journey as the destination. Every discovery opens new doors, leading to further questions and deeper mysteries. Whether the answer lies in quantum fluctuations, dark energy, cyclic universes, or the multiverse, the quest to understand our origins will continue to inspire curiosity, wonder, and the drive to explore the infinite. Perhaps, in the pursuit of answers, we will uncover not only the secrets of the universe but also new insights into ourselves and our place in the grand tapestry of existence. Eternal cycles and the nature of time. The idea that the Big Bang is not a one-time event but part of an undying cycle suggests that universes continually emerge, collapse, and renew. This speculation implies that our universe may have been restored from the remnants of a previous one. In this cyclic pattern of compression and expansion, there is no definitive beginning, but rather an eternal series of universes creating, dissolving, and recreating themselves. Cyclic cosmology raises profound questions about the nature of time, suggesting that time itself may not move linearly but could repeat in cycles. If this hypothesis is correct, it could mean that what existed before the Big Bang was simply another form of the universe, one that collapsed only to give birth to our current cosmos. For scientists, this speculation offers a radical answer to the question of origins. There may be no clear starting point, and the universe has always existed in some form, transcending our perception of time and existence. Gravitational waves and pre-Big Bang clues. Gravitational waves, discovered in 2015, provide another fascinating avenue to explore what might have existed before the Big Bang. These ripples in spacetime, caused by massive objects like black holes or colliding neutron stars, can travel vast distances and carry information about the events that created them. Some physicists suggest that gravitational waves from before the Big Bang might hold clues about the universe's state before inflation began. These waves could carry traces of events beyond our conventional understanding, potentially pointing to a grander structure beyond the observable universe. If such signals exist, they could reveal remnants of a previous universe or an event that preceded the Big Bang. Detecting and interpreting these faint imprints would require advanced technology, but their discovery could revolutionize our understanding, much like the discovery of the Big Bang itself. Beyond physics. A metaphysical reality. As we probe deeper into the mysteries of existence, the boundaries between physics and metaphysics blur. If the universe as we know it emerged from nothingness or quantum fluctuations, what governed the forces and particles in that pre-Big Bang state? Some theories suggest the existence of a fundamental layer of reality that transcends space and time, where the usual laws of physics no longer apply. This metaphysical realm could defy everything we currently understand about the universe but might hold the answers to the most profound questions. For instance, string theory posits that the building blocks of matter are not point-like particles but one-dimensional strings, vibrating at different frequencies. These strings could exist in higher-dimensional spaces beyond the three-dimensional world we observe. If true, our universe might be one slice of a higher-dimensional reality, interacting with others to form a multiverse. The ekpyrotic model, for example, suggests that our universe arose from a collision between two higher-dimensional brains within a multidimensional space. These collisions could have triggered Big Bang-like events, initiating cycles of expansion and contraction. Philosophical questions and the limits of understanding. These cosmological theories raise profound philosophical questions about the nature of existence. If time, space, and matter have always existed in some form, does this imply a timeless and continuous reality beyond human perception? Or are we part of an eternal cycle of creation, expansion, and destruction? Some argue that the answers to these questions may lie outside the realm of science, and may only be fully understood through spiritual or philosophical inquiry. This suggests that the limits of human understanding are not only about advances in physics but also about the fundamental existential nature of reality itself. The endless quest. As we explore the question of what existed before the Big Bang, we are reminded that science is a journey without end. Each discovery leads to new mysteries, and each mystery inspires further exploration. The quest to understand the origins of the universe is not merely a scientific endeavor but a profound human pursuit. It compels us to look beyond the boundaries of our knowledge, to question the nature of existence, and to seek meaning in the vastness of the cosmos. Whether the answers lie in quantum mechanics, cyclic universes, multiverses, or dimensions beyond our comprehension, the journey itself reveals the infinite potential of human curiosity. In the process, we uncover not only the secrets of the universe but also the deeper truths about ourselves and our place in the grand cosmic order.